Okay, so let's talk about something you probably use every single day, something you don't even think twice about: the electric fan. What is actually making it spin? Well, the answer is this kind of everyday magic, and we're about to pull back the curtain and see exactly how the trick is done. I want you to picture this. You're at home, maybe it's a warm day, the fan is humming away, and then boom, silence, darkness. The whole world just stops for a second. It all starts with a moment we've all been through: a power cut. And in that sudden quiet, has your mind ever started to wander? Have you ever really stopped and wondered, like the boy Nears in our story, where does that electricity really come from? I don't just mean the wires outside your window, but the source of it all. So, what is the secret? Well, that little bit of everyday magic actually has a name, and it all goes back to one single incredible discovery. Let's dive right in with our first section: Faraday's secret principle. The answer to Neeraj's question, the reason your fan spins and your lights switch on, it's a concept called electromagnetic induction. Now, that sounds like a total mouthful, I know, but trust me, the idea behind it is actually beautiful and honestly pretty simple. To get it, we've got to jump in a time machine and go way back. All the way back to 1831, where this brilliant scientist, Michael Faraday, was doing a bunch of experiments. And what he found? Well, it was the principle that would quite literally light up our entire world. So what is electromagnetic induction? Put simply, it's the magic of creating an electric current in something like a copper wire just by moving it through a magnetic field. That's it. That's the core recipe. You just need a wire, a magnet, and a little bit of motion. Okay, so we have the name, we have the basic idea, but how does this trick actually work in the real world? What are the ingredients you need? Let's break it down in section 2, the rules of induction. It really just boils down to 3 simple steps. First, you need a conductor. Think of any copper wire. Second, you need a magnetic field, which you get from, a magnet. And third, and this is the absolute key, you need relative motion. You got to move that wire past the magnet or move the magnet past the wire. Do that, and presto, you get an electric current. It's induced right there in the wire. And Faraday, being the genius he was, didn't just figure out that it works. He figured out how well it works. We call it Faraday's law. Now, this quote on the screen sounds super technical, but it basically means something really simple. The faster you move the wire, or the stronger the magnet you use, the more electricity you generate. That's it. More speed equals more power. All right, so a tiny wire and a little magnet can make a teeny bit of current. That's cool for a lab, but hold on. How do we get from that little spark to powering an entire city? Well, this is where we see how that small principle gets scaled up to an absolutely massive level. We're talking about the world's biggest engines. And I am not exaggerating when I say this, that one single, elegant principle, just moving a wire through a magnetic field, is the engine that runs our entire modern world. Almost every single watt of electricity we use starts with this one simple idea. Just look at this comparison. It's kind of mind-blowing. On the one hand, you've got Faraday's simple little experiment: a wire and a magnet. And on the other, a generator from a power plant. It's the exact same principle. But instead of one little wire, you have massive, heavy coils of it. And instead of a fridge magnet, you have giant, incredibly powerful electromagnets. Same idea, just on an epic scale. So here's the kicker. Inside our power plants, they use these huge turbines, which are spun by steam or by the force of a river or by the winds. And their whole job is to spin those massive coils of wire inside those magnetic fields at unbelievable speeds. And that constant, super fast spinning is what generates the enormous, steady flow of electricity that ends up in our homes. Okay, let's bring it all the way back. We've gone from a dark room during a power cut to a lab in the 1800s to a gigantic power plant. Now for the final piece of the puzzle. Let's connect that giant spinning turbine directly to the fan in your room. This is the aha moment. You see, the journey of that electricity is a direct, unbroken line. It flows from that spinning generator, zipping through miles and miles of power lines, and right into the outlets in your walls. Which means that fan in your room, yeah, the one keeping you cool right now, it's powered by electromagnetic induction. The lights over your head, same deal. The computer or phone you're watching this on, you guessed it, they're all the final destination for a giant version of Faraday's simple little experiment. And that, right there, is the secret of the electric fan. It's what Neeraj finally figured out during his power cut. It all starts with a simple rotation, a massive coil of wire spinning inside a magnetic field, maybe hundreds of miles away from you. So, the next time you feel that cool breeze from a fan, you'll know the incredible scientific journey that power took to get to you. Now that you know the fan's secret, it kind of makes you wonder, doesn't it? What other amazing scientific secrets are hiding out there just in plain sight?